Here we'll discuss questions on integrals from the past 12 years of JEE advanced papers, and here is the first question. Here something about the function f of x is given, integral 0 to pi by 3 f of t dt is given to be 0. Using that we have to see which of these options are true. Let's do it one by one. So the first equation, right, f of x minus 3 cos x equal to 0 has solution or not. So let us take this function, right, let's take some g of x to be that function, right, f of x minus 3 cos 3x. Now we have to see whether this g of x equal to 0 has a solution or not, right? So let us find. Now what we do, so let us do the integration of this. So integral 0 to pi by 3, so g of x dx. So that equals, so this integral 0 to pi by 3 f of x dx, let us separate it, minus 3 integral 0 to pi by 3 cos 3x dx. So we are doing this integration because we know this integral f of x dx. So we are integrating both the sides. So let us find this value. This value is given in the question, so that is 0. So this value is 0, but that can be found. So minus, so 3, so cos 3x. So that has integral sine 3x divided that by 3, and the limit is from 0 to pi by 3. So this value is, okay, so this is sine, this is 0, right? So this value is 0 again, because so sine pi, so that is 0, sine 0 is also 0, so the whole integral is 0. The integral g of x dx, so that is 0. What does it mean? Integration means what? Area, right? So we find the area. So this integration is 0. So can this integrand, right, g of x be completely positive? Is it possible? If the integrand is positive, g of x is positive, and the limit is from 0 to pi by 3, so this integral will never be 0. If the value is positive, this is going to be positive, right? And if g of x is only negative, the integral will also be negative, right? But because it is 0, for some values it must be positive, for some value it must be negative, right? So g of x must be like this. For some value it is positive, some value it is negative. So definitely the curve will intersect x-axis at some point. So definitely this equation will have a root. G of x equal to 0 has a root. So this implies g of x equal to 0 has a root. For some value it will definitely intersect x-axis, right? Because the integral of this is 0, so that means for some value it has to be positive, some value it is negative, and it is continuous, so that means it will intersect x-axis at some point. So this g of x can be equal to 0 at some point. Is that okay? So that is the first one. Okay, now let's do the same thing for the next function also, right? So the second one, so again you give it a name, right? I'm using the same symbol, right? G of x equal to, so this time the function is fx minus 3 sine 3x plus 6 by pi. Okay, so this can be 0 at some point or not. So that we have to check using the same method. Let us do the integration, right? So integration 0 to pi by 3, so g of x dx. So that equals integration of f of x dx. So that we have already found, we know the value. So minus, so 3. So sine 3x integration is what? So that is cos 3x. Okay, minus cos 3x. So 3 gets cancelled. So from limit 0 to pi by 3 and 6 by pi. So that is x from 0 to pi by 3. Alright, so let's substitute the limits. So if you substitute here, so cos pi. So cos pi is minus 1 minus of 0, so that is simply minus 2, and here if you substitute 6 by pi, if you substitute the limits of pi by 3, so this will give you the value 2 minus 2, again 0, so this value is again 0. So that means integral g of 0 to pi by 3 g of x dx is 0 even here, right? Just like here also it is 0, so same conclusion. So that implies, so g of x equal to 0 has a root. Okay, so same thing, same method, right? Integral g of x dx is 0, that means g of x has to be positive for some values and negative for some values, just like here. Okay, so that means g of this time also, so g of x equal to 0 has a root in that interval. Is that okay? Yes. Next we have to find some limit, right? Let's find this limit. So that is the third one. So that is limit x tends to 0, x integral 0 to x f of t dt. So divided by 1 minus e to the power x square. So this limit we have to find. Now here we have an integral with a variable limit. Obviously we have to differentiate. So we have to differentiate this. So that means we have to use L'Hopital rule. So let us differentiate this. But before that, let's simplify this. So we divide this by x square because it is of the form multiply and divide by x square. So this is of the form e to the power x minus 1 by x. So that is the exponential limit. We have the formula, right? E to the power x minus 1 divided by x square, that tends to 1. But here it is 1 minus. So 1 minus e to the power x square, here also x square. So that tends to minus 1. So this limit is done separately. So that value is minus 1. So the rest of the things can be simplified. So 1x gets cancelled. So this becomes limit x tends to 0 integral 0 to x f of t dt divided by, so this x and this limit is found separately, so minus 1. Okay, now we can use L'Hopital rule. So if you use L'Hopital rule here, so we have to differentiate this. So let us differentiate this. So limit x tends to 0. So this derivative is, that is Leibniz rule, right? Directly we have to substitute here f of x because x derivative is anyway 1. So divided by, so this is minus 1, that's all. Now you apply the limit, right? Substitute x 0. So f of 0, so that value is given in the question 1. So this value is minus 1. So minus 1 is the value of this limit, right? Yes, that is done. Now the next one, so we have, similarly we have another limit x tends to 0. So sin x integral 0 to x f of t dt divided by x square. But x square can be written as x multiplied by x, right? Because we have the formula sin x by x, so that tends to 1. So this limit is done separately, so that value is 1. So only this limit we have to find. Again we have to use L'Hopital rule, differentiate. Limit x tends to 0. So this derivative is again f of x divided by, this part is done separately, right? So that is 1. Now this limit is 1. So again x tends to 0, f of 0 tends to, so that is 1. So that means this value is 1. So this limit has value 1. But what is given here is minus 1. So that is not correct, right? So except the option D, so the rest of the options are correct. Here some functions are given, g1, g2 and f of x. We have to find two integrals, s1 and s2. Let's find them one by one. So s1 we have to find first. So s1 is given to be integral, say pi by 8 to 3 pi by 8. So s1 is what? g1 of x multiplied by f of x, right? g1 of x is given in the question, that is simply 1. 1 multiplied by f of x, so that is simply sin square x, that's all. So this integral is very easy to find, right? So we have to just write sin square x as, so we can use some trigonometric identities. So pi by 8 to 3 pi by 8. Sin square x can be written as 1 minus cos 2x divided by 2 dx. Okay, yes. Now we can do the integration directly. So this can be written as, so 1 by 2. So that is 1. Integration is x minus sin 2x divided by 2. So that will give you, okay, so the limits are 3 pi by 8. So let us do the substitution here. So if you substitute this one, so this is 1 by 2. So x 3 pi by 8 minus pi by 8, that is 2 pi by 8, so that is pi by 4. I am writing directly, so this is pi by 4 minus of, so 1 by 2 multiplied by, now substitute 3 pi by 8. So we will get, so 2 times 3 pi by 8, 3 pi by 4. So sin 3 pi by 4, so that is 1 by root 2. Similarly, minus of sin pi by 4, that is also 1 by root 2. So this becomes 0. Alright, so I have written directly simple substitution, right? Upper limit and lower limit, just substitute, we get 0. So that means this answer is pi by 8. So that is S1. That's all, simple, right? Now S1 is found. Now what we have to find is 16 S1 by pi. So let us find 16 S1 by pi. So that equals 16 by pi multiplied by S1. So that's what we found here. So pi by 8. So that gives you the value 2. So 2 is the value, right? So that is the answer to the first question. Now we have to find S2. Okay, so let's find S2. So what is S2? So that is g2 of x, right? g2 of x, so that is 4x minus pi, right? So modulus of 4x minus pi multiplied by f of x, so that is sin square x dx. So that's it. Alright, so now let us find this integral. Now modulus is there, so we have to split the integral into two parts. So where this function becomes 0, at that point we have to split it, because we want to know where this function 4x minus pi is positive, negative. I think it is at the point pi by 4. So less than pi by 4, greater than pi by 4, we have to split it into two parts. But instead, let us try something else. We can use the properties of the definite integral. See, we can use this property, a plus b minus x. See, we know that integral a to b f of x dx is same as integral a to b f of a plus b minus x. So that property can be used. But what is a plus b here? So that is 4 pi by a, that means pi by 2. You can replace this x by pi by 2 minus x, right? So what will you get if you replace x by pi by 2 minus x? So the same integral s2 will become, so integral pi by 8 to 3 pi by 8. So here you replace this pi by 2 minus x, so that means it will become 2 pi minus 4x minus pi. So that is same as pi minus 4x, pi minus 4x, but inside modulus pi minus 4x or 4x minus pi, so both are same. So that means you can write the same thing, 4x minus pi. Okay, we can do the calculation I've written directly. Even if you replace pi by 2 minus x, okay, x by pi by 2 minus x, still we are getting the same value. But what about this function, sine square pi by 2 minus x, sine pi by 2 minus x, that is cos x. So this will become cos square x dx. Alright, so we're just using this property. Okay, now what we can do, because these two functions are same, so sine square x, cos square x, we simply add these two. Okay, just add. So if you add this, we get 2 times s2, so that equals, so pi by 8 to 3 pi by 8. Now this is common, 4x minus pi, and this sine square x plus cos square x, so that will become 1. Okay, so this multiplied by 1 dx, so that's all. So that is gone. We have only this function 4x minus pi modulus, right? So that integral we can easily find. Now we can split it into two parts, so it is easier to do. So let us do this integral. Okay, so let's do it. So that equals, you can also do one thing. Okay, instead of doing the integral, okay, we can also use some geometry. Okay, so we can find the area. We have to find, see, pi by 8 and 3 pi by 8. This is the interval in which we have to find this value, right? Now this is modulus function, so at pi by 4 it becomes 0, so that means at pi by 4, so the graph will be like this. So I hope you remember modulus function, because modulus curve is this thing, but it is shifted. So this is the graph roughly. Now instead of finding the integral, we can find the area, right? So what is the area of this triangle and this triangle? So that area is the integral, right? So you usually find the area using integral. Now we want to find integral. Now we make use of area. We can directly also find, right? We can split it into two integrals at the point pi by 4, and then we can directly integrate it, but I am making use of this area. So what is the area of this triangle? So half, right? Let's find the area. So that is 2 times the area, because these two triangles are same, right? Same area. So we find the area of one triangle, multiply by 2. So this is 2 multiplied by, so area of that triangle. So that is half base. The base length is what? Pi by 4 minus pi by 8. So that is pi by 8 multiplied by the height. So the height is, when x is pi by 8. So when x is pi by 8, what is the value? So that is, so pi by 2 minus pi. So that is pi by 2. So half base height. So that's also, this is the value of 2s2. Now if you simplify this, so we get the value of s2. So that equals, so this is pi square divided by, so this is 32. Okay, so we got the value of s2. So substitute in the given expression here. So what we need to find is 48 s2 divided by pi square. So that is 48 by pi square multiplied by pi square divided by 32. So that equals, pi square gets cancelled. So this is 48 divided by 32, right? So that is equal to 3 by 2, right? So 1.5. So that's also, that is our required answer, 48 s2 by pi square. So that is 1.5. So that is the answer to the second question. Let's find the value of I. So that is an integral which contains an integer part function. So for an integral containing an integer part function, we have to split it at the points where the integrand, the function inside the integer part, becomes an integer, right? See here, so what we have is, see, first of all, let's consider only this part, okay, 10x divided by, so that is x plus 1. Let us first find the range of this. So obviously the minimum value is 0, right? Because we can't consider negative values, because this expression is inside a square root. So minimum is 0. But what is the maximum value of this? So let's write it like this. So 10 multiplied by you add 1 and subtract 1, okay, like this. So divided by x plus 1, so that becomes 10 multiplied by, this is 1, so 1 minus 1 by x plus 1. Okay, so this is the value of the integral, right? So what can be the maximum value of this? So this is 10 minus something, right? So the 10 minus some positive value. So that means obviously it is less than 10. So the whole value is less than 10. So the value of the function inside is less than 10. Okay, that means for this inside function, this function 10x divided by x plus 1 to be a perfect square, it has to be a perfect square. Why? Because it is inside a square root. For this to be an integer, it has to be a perfect square. But what are the perfect squares possible? So because it is already less than 10, the only perfect square values are 1, 4, 9. Only 3 possible values. Let us consider one by one. Okay, so the first case, so that is 10x divided by, so 10x divided by x plus 1. So that may be equal to 1. So that gives you the value of x, so that equals, so this is 9x equal to 1, so x equal to 1 divided by 9, which means when x is 1 by 9, so this function becomes an integer, right? The value inside the integer part function, that becomes an integer, which means we have to split the integral at that point. Now similarly, there are other possibilities like 10x divided by x plus 1 may be equal to the next perfect square, that is 4. So what is the value of x satisfying this condition? So this is 6x equal to 4, so that means x equal to 2 by 3. Similarly, the next possible value is x plus 1, so that equals 9. So 9 is the next perfect square, so that gives you the value of x, which is 10x minus 9x, so that is x equal to say 9. So 9 is the value. So we have to separate, okay, split the integral at these points, okay, 1 by 9, 2 by 3 and 9. Okay, let us do this. The first one, the given integral, so it starts from 0 to 1 by 9, 0 to 1 by 9, and then again from 1 by 9 to 2 by 3, and then from 2 by 3 to 9, and then from 9 to 10. Okay, so let us split it. Now when x lies between 0 and 1 by 9, so this value, the integer part is 1, right? So integer part is 1, right? Because so this value is 1, because we have assumed that this expression is 1, that means less than 1 by 9, so this value is less than 1. When a function inside the integer part is less than 1, the value is 0, it is already positive, so 0 ds. Do you understand? Less than 1 by 9, so this is less than 1. At 1 by 9 it is exactly equal to 1, the function is increasing, so this is less than 1. Less than 1, the integer part is 0. From 1 by 9 to 2 by 3, this value is greater than 1 but less than 4, which means the square root of that is between 1 and 2. The number is between 1 and 2, the integer part is simply 1. Similarly, next one, 2 by 3 to 9, so that means the function becomes lying between 4 and 9. So that means the square root of that lies between 2 and 3. So 2 and 3, what is the integer part? So that is 2. Plus similarly, so from 9 to 10, so this value is greater than 9, right? So greater than 9, which means the square root of that is 3. So more than 3, so that is 3 dx. Okay, so that's it. So let us do the integral, that's all. So this is 0, so plus that is 1, which means 2 by 3 minus 1 by 9 plus 2 multiplied by, so that is 9 minus 2 by 3 plus 3 multiplied by 10 minus 9. So let us simplify this. So this is so 6 minus 1, so 5 by 9 plus this is 27 minus 2, so 25, so 50 divided by 3 plus 3, so that equals, so this is 150 plus 5, right? So 150 plus 5, so that is 155 divided by 9 plus 3. So if you simplify this further, so that is 27 plus 155, so that is 182 divided by 9. So that's all. So that is our required value of the integral. So that is the value of I. So but what we want is 9i, so that implies the value of 9i, so that equals 182. So that is the required answer. Do you understand? See, so this is the standard method. So when we have an integrand having an integer part function, we have to split it at the point where it becomes integer. Alright, the only possible integers are here, so these are the values, right? Because it is less than 10, so the value inside the square root has to be a perfect square. The only perfect squares are 1, 4 and 9. So for what values of x, so the function becomes 1, 4 and 9. That is the point at which we have to split the function integral. So we have split it, and then all these integrants are constants now. We can simply integrate it. So finally we got the answer 9i 182. Okay. Here some functions are given, f, g, psi1, psi2, etc. Now we have to find some conditions satisfied by these functions. Let us simplify these functions one by one, right? What is the function f of x? So that is given as the integral, right? So minus x to x modulus of t minus t square e to the power minus t square dt. Now here the limit is from minus x to x. Then we have to check whether the function is even or odd. So here it is modulus of t square, t square. So that means it is an even function. For an even function, minus x to x, so that can be written as 2 times integral 0 to x modulus of t minus t square e to the power minus t square dt. So this is the function f of x. Similarly, let's simplify the function g of x. Okay, so g of x, so that function is given as integral 0 to x square, so that is root t e to the power minus t dt. Okay, so let's simplify this function. What we do is we'll take some substitution, t equal to, so because it is inside the square roots, let us take t equal to some u square. Okay, then you'll get dt, so that equals 2u du. Okay, so let's simplify this, substitute the limits. So 0, so when t is 0, u is 0, and when t is x square, u is x, and this is root t, right? So root t is same as u, and then e to the power minus t, so minus u square multiplied by dt, dt is 2u du, so multiply by 2u du, or you can write 2u square du. Do you understand? Yes. Now if you observe, there is some relation between this function g of x and this function f of x. This part is same, 2t square e to the power t square. So here also we have 2e square e to the power minus u square. U or t doesn't matter. We can replace this u by t only. So no problem. 2u square is e to the power minus u square. Here also like 2u square e to the power minus u square. If you add these two, so add these two functions. So we get fx plus gx. So that equals, so same limit, so integral 0 to x. This term gets cancelled, right? 2t square e to the t minus t square. Here also 2t square e to the power minus t square. Only this term will be left. So we'll get 2, that is modulus of t e to the power minus t square dt. Okay, so this is f of x plus g of x. Now this modulus is not required, right? 0 to x, right? Positive modulus is not required, so we can simply write it as 2t e to the power minus t square, right? So 2t, so t square, you can do substitution method, so t square can be taken as some other new variable, so that's derivative is 2t dt, so it is like e to the power minus some v, e to the power minus v dv. So I'm directly writing, you can do the substitution if you want. So t square is taken as some new variable, its derivative is already there, so the integral of this is directly e to the power minus something, so minus e to the power minus t square. So that's all. So that is from 0 to x. If you simplify, substitute the limit, you get 1 minus e to the power minus x square. So that's all. That is the value of f of x plus g of x, right? But what we need is something like f of root ln 3 and root ln 3. That means we are substituting x equal to, so ln 3 plus g of root ln 3, which means in place of x you substitute this log 3, right? So what will you get here? So 1 minus e to the power minus x square is ln 3. So that is same as 1 minus, so this is e to the 1 divided by e to the power log 3, so that is 1 by 3. That means we get the value 2 divided by 3. So we are getting this value 2 by 3. But what is given here is 1 by 3. So that is not correct. Okay. So this is one thing. And now we have to see whether this function, right, f of x is increasing or not, right, f of x. For that we have to find the derivative. So let us find the derivative. So f dash x. What is f dash of x? Let us differentiate this expression. Okay. Because the lower limit is constant here. So if you differentiate this using Leibniz rule, you directly have to substitute the upper limit. That's all. So it is 2 and then modulus of x minus x square multiplied by e to the power minus x square. Is it always positive? No, because modulus of x minus x square, right? For greater than 1, less than 1, it takes different sign, right? So That means it is not a positive value, nor is it a negative value completely. For some values it is positive, some value it is negative. It is not an increasing or decreasing function, not an increasing function or decreasing function in the entire positive part of the interval, right? So that is not correct. Now next one, so the options B and C almost look like a similar expression. What we do is, so we find this psi 1, right? Psi 1 is given, psi 2 is given. Let us find the derivative of this psi 2. Psi 2x derivative. Okay, what is the derivative of psi 2? So that is 2x minus 2 plus 2 e to the power minus x. Okay, so if you simplify this, so this 2, if you take common from these two terms, you'll get 2 multiplied by x plus e to the power minus x. So that is same as this psi 1 of x, right? So that means it is 2 psi 1 of x minus 2. So they are related, right? Psi 2 dash, right? The derivative of psi 2 is same as 2 times psi 1 of x minus 2. Now what we are going to do is, we'll use Lagrange's mean value theorem. Okay, so we have to use Lagrange's mean value theorem for the function psi 2. What is Lagrange's mean value theorem? So psi 2 of x and 0 I am taking, psi 2 of x minus psi 2 of 0 divided by x minus 0. So that equals, so that is Lagrange's mean value theorem, right? So that equals, so the derivative psi 2 dash, at some point, that point is taken as some beta, right? So that is the formula for Lagrange's mean value theorem. Okay, so psi 2 of x, so let's simplify, this is 0. So psi 2 of x, so that equals x multiplied by, but what is psi 2 dash of beta? That's what we found here. Psi 2 dash equal to, this is the relation, so that can be substituted here. So x multiplied by 2 psi 1 of beta minus 2. So that's all. So that means we are getting something like this, psi 2 of x equals 2x multiplied by psi 1 of x minus 1. Okay, so that is the relation. I think this is what is given here. So that is our required answer to the question. Okay, yep. This question is the continuation of the last paragraph question only. We have to find some conditions satisfied by the functions psi 1 and psi 2. Okay, yes. Now the first option given here is the psi 1 of x is always less than or equal to 1. Is it true? So what is psi 1 of x? So that is e to the power minus x plus x. Is it always less than or equal to 1? Obviously not, right? As x increases, this is anyway positive. So as x increases, this tends to infinity, right? As x tends to infinity, this tends to infinity. This is not less than or equal to 1. Or if you take a simple example, okay, so psi 1 of say 2. So that will become e to the power minus 2 plus 2. So this value is always greater than 2 or particularly greater than 1. So that means, so we don't, this option is not true, right? This is not less than or equal to 1. Similarly, the next option, so psi 2 of x, psi 2 of x, so that is less than or equal to 0. Is it always less than or equal to 0? What is psi 2 of x? So that is x square minus 2x minus 2 e to the power minus x plus 2. Is it always negative? Let us see. So if you simply substitute some value, right, psi 2 of some 2, let us substitute 2 here also. Okay, so that is 2 square minus 4, so that is 0. So this will become minus 2 divided by e square plus 2. So this value is positive, correct or no? So this value is less than 2. 2 divided by something, so this is less than 2. 2 minus something less than 2, that is positive. So this value is positive, so that means it is also not true. Now the next two options, we have to follow the same method. We have to use the series, right, the exponential series. Let us take this option 3, option 4, right? So what do you do? So g of x. So what is g of x? G of x equals, so that is integral, okay, 0 to x square root t. So we write it as t to the power half and e to the power minus t dt. So we'll use the exponential series here because this is a polynomial expression. So this is exponential. So this also you convert into a polynomial expression so that we can combine them. So it is t to the power half. What is exponential series? 1 minus t divided by 1 factorial plus t square divided by 2 factorial minus t cube divided by 3 factorial, so etc., right? So there are many more terms, infinite terms actually. So this till infinity, so dt. Okay, yes. Now so you do the multiplication here. So this value is integral 0 to x t to the power 1 by 2 minus t to the power, so this is 3 by 2 and plus t to the power, so 2 plus 1 by 2, so that is 5 by 2 divided by 2 minus t to the power 3 plus 1 by 2. So that is 7 by 2 divided by 6 plus etc. So dt. Okay, now we are not going to take all infinite terms, right? So only first 3 terms you take. So this term minus something, so that equal to the whole term. But if you subtract something, so that value will become less than this value, so which means the whole expression is less than equal to, the whole expression is less than equal to 0 to x. I'm only taking the first 3 terms, so t to the power half minus t to the power 3 by 2 plus t to the power 5 by 2 divided by 2, that's all. Only these 3 terms we take, because this is subtraction, right? We are subtracting something, so that will be less than this, right? So which means this value is greater than that value, because so this is subtracted, so this whole value is less than equal to, so only this value. Alright, yes, now you only have to do the integration of this. What do you get this one? So that is less than equal to t to the power 3 by 2 divided by 3 by 2 or 2 by 3. Similarly, minus t to the power 5 by 2 divided by 5 by 2, 2 by 5. So plus t to the power 7 by 2 divided by 7 by 2, so get 7 and substitute the limits 0 to x. Okay. Yes. Now actually the limit is from 0 to x square, right? G of x has limit 0 to x square here. So it is square. So substitute the upper limit and lower limit. So we will get, lower limit is anyway 0. Substitute the upper limit. So this value is less than equal to, so x square if you substitute, we get x to the power 3. So which means 2x cube divided by 3 minus, similarly here 2x to the power 5 divided by 5, and this is plus, so x to the power 7 divided by 7. So that's what is given, I think. So g of x, the given function g of x is less than equal to this expression, right? 2x cube by 3 minus 2x to the power 5 by 5 plus x to the power 7 by 7. So that is the required answer. Okay. Here some integrals are given, we have to verify some inequalities, right? So let us do this one by one. So the first one is integral 0 to 1 x cos x dx. See, this can be done directly also using integration by parts. So if you do that, so cos x we have to substitute the upper limit cos 1 or sin 1 value, so that we don't know. So we use another method. X is an algebraic expression. Cos x can also be written in terms of an algebraic expression. We have the series expansion of cos, right? So cos x series can be used here instead of using integration by parts. So this is 0 to 1 x. So cos x series is what? 1 minus x squared divided by 2 factorial plus x to the power 4 divided by 4 factorial, etc. So infinite terms are there. Okay, yes. Now we are not going to use all the infinite terms. We only take first 2 terms. So first 2 terms plus something. That means this whole expression is definitely greater than this value, 1 minus x squared by 2 factorial, right? Only 2 terms you take. So that will definitely be less than this whole expression because we have added. Okay, so that means this whole value is always greater than or equal to, just take only 2 values now. 2 terms, 1 minus x squared divided by 2. Okay, so dx. So that's all. So you just do the integral, not exactly equal. It is greater than equal to, because we have added some many more values. We have taken only 2 values here, 2 terms. Okay, now let us do the integration here. So that is greater than equal to, so this is x. So x integration is x squared by 2 minus, this is x cubed divided by 2. So that is x to the power 4 divided by 8. So that is from 0 to 1. So that will give you a required answer. This is 1 by 2 minus 1 by 8. So 3 minus 1, sorry, 4 minus 1, 3, 3 by 8. So this whole value is greater than equal to 3 by 8. So that is the answer to the first question, right? X cos x, right? Integral 0 to 1 x cos x is greater than equal to 3 by 2. Now we also have to find this one, integral 0 to 1 x square cos x. X square cos x dx. Okay, so let us find this. This can also be done by the same method, right? So we can use the series here, x square multiplied by that series, but instead of that we can also try something like this. See, cos x is less than equal to 1, so that means the whole value is less than equal to 0 to 1 x square multiplied by 1 dx. X square I am keeping as it is, so cos x is less than equal to 1. So that's all. So the whole expression is less than equal to x square dx, right? That's all. Let us do the integration of this. So that is less than equal to x cubed divided by 3. So this value is less than equal to 1 divided by 3 after substituting the limits, right? So this second integral x square cos x is less than equal to 1 by 3, right? So it is definitely not greater than equal to 1 by 2. because it is already less than equal to 1 by 3, so it is not greater than equal to 1 by 2, so that is not possible. You understand? So that is rejected. So now you do the next one, integral x sin x now. So same thing we have to do almost, integral 0 to 1 x sin x dx. So this time we have to use sine series, that's all. So 0 to 1 x, what is sine series? X minus x cube divided by 3 factorial plus x to the power 5 divided by 5 factorial, etc. Okay, now we will do the same thing here. So what do? You just take the first two terms. So the whole value, you added these values, the whole value is greater than equal to, so greater than equal to only the first two terms. X multiplied by x minus x cube divided by 3 factorial. So that is 6. So dx. So that's it. So that is greater than equal to, so this is x square. So x square integration is x cube divided by 3. You can substitute directly. So 1 by 3. X cube divided by 3. 1 can be substituted. So 1 by 3 minus this is x to the power 4. So that is x to the power 5 divided by 5. So that is 1 divided by 5 times 6. So that is 30. So this value is greater than equal to 9 divided by 30. So that means, so this is it correct? So x sin x, so that is greater than equal to, yeah, 3 by 10. So this is 3 by 10. So x sin x integral, so that is greater than equal to 3 by 10. So that is done. Now similarly, we have to do the next one, integral 0 to 1 x square sin x. X square sin x dx. So we'll do the same thing. So this value is greater than equal to integral 0 to 1 x square multiplied by, we'll only write the first two terms. Instead of x, we have x square. That's the only difference. So what is this? So x minus x cube divided by 3 factorial. So that is 6. So dx. So that is greater than equal to x cube. So x cube is x to the power 4 by 4. So 1 by 4 minus this is x to the power 5. So x to the power 5, so that integral is x to the power 6 divided by 6. So 1 if you substitute, so 1 divided by 6, already 6, so 36. So that is approximately, so this is 9 minus 1, so 8 divided by 36. So 8 divided by 36, that means the whole value is greater than equal to, so if you cancel 4, so it is 2 divided by 9. So that means integral 0 to 1 x square sin x is greater than equal to 2 by 9. So that is also correct. So these are the 4 integrals given. So we verified each one of this. Okay, yes. So the answer here is this one. The first one is correct, right? X cos x is greater than equal to 3 by 8. The next one, x sin x is greater than equal to 3 by 10. So that is also correct. And also x square cos x is not greater than equal to 1 by 2. And x square sin x is greater than equal to 2 by 9. So that is the answer. Two functions are given, f of x and capital F of x, and they are related, right? Using this relation, we have to find the value of f of 0. Let's find it, right? So first of all, so this is a simple condition, capital F of x equal to integral 0 to x f of t dt. So what we have to do, obviously we have to differentiate, right? So to remove this integral, so if you differentiate, so this becomes f dash x, so that equals, so Leibniz rule again, so f of x, that's all. So f dash of x equal to, so this small f of x. Okay, so this is one relation. Now we have to find, so that integral. So that integral is actually integral 0 to pi f dash of x multiplied by cos x dx. I'm splitting it into two parts, right? So integral 0 to pi, and then next one, capital F of x multiplied by cos x. So now product of two functions, let us use integration by parts. Okay, but here f dash of x is there, it is better to take that as v, because we need the integration of that. So f dash is there, integration is easier. So you take this as v, this as u. So this is the first function u, and this function is taken as v. But here we will take the other way around, because we want the derivative of this, right? So derivative of that is known. So you take this as u and that as v. So this is u, this is taken as v, right? So use integration by parts. Okay, yes. So what do you get here? So u multiplied by cos x multiplied by the integration of this. So the integration of f dash of x, so that is f of x. Okay, minus integration of the derivative of cos x, so that is minus sin x, or it will become plus sin x, then plus sin x multiplied by this same function f of x dx. Okay, so the limit is there from 0 to pi. Okay, yes, done. So this part is done. Similarly here, so we will use integration by parts again. So this is u, that is f of x, multiplied by integration of v, that is sin x, minus integration of, so the limit is there 0 to pi, minus integration of the derivative of this u, so that is f dash of x, multiplied by the integration of cos x, so that is sin x already. So yeah, yes, so let us substitute this limit. Okay, substitute pi here, so we will get, so this limit is also known, so 0 to pi. So let us substitute this value, right, upper limit. So cos pi is minus 1, so minus 1 multiplied by f of pi. Okay, now substitute 0. Okay, so we get minus cos 0 is 1, so f of 0. Okay, so this is the first one. Now, so this we will keep as it is, plus integral 0 to pi sin x f of x dx. Now here also you substitute pi. If you substitute pi, sin pi, that is 0, and if you substitute lower limit, that is also 0. So the whole integral, this value becomes 0. Now what is f dash of x? Capital F dash of x. So that's what we have formed to be small f of x. So that second integral, that becomes integral 0 to pi small f of x, right, into multiplied by sin x dx. Okay, now this term gets cancelled, right? So sin x f of x dx. So here also sin x f of x dx. So this integral gets cancelled. So we're just left with this one. Okay, so what do you get? F of pi, but that is also given in the question. F of pi is given as minus 6. That means this value is 6 minus f of 0. So this is the value of the integral. So we found it. But this value is already given in the question. So this is given to be, so this value is given to be 2. So this is equal to 2. That's all. Solve it. We will get the value of our required f of 0. So that is 6 minus 2, 4. So that's all. So 4 is the value of f of 0. So that's it, right? So we just do the differentiation, obviously, right? Because we need to remove this integral with variable limit. So we do the differentiation. So we got some relation. To find that integral, we have to use obviously integration by parts, because product of functions, we use integration by parts and we get this answer. So f of 0 is 4. Okay. This is a question on limit summation. So that should be converted into an integration, right? So what is the rule? Limit summation becomes integral 0 to 1 and r by n becomes x and also 1 by n becomes dx. So these are the rules. So let us do these two things separately, the numerator and denominator. So numerator is 1 summation. Similarly, the denominator, let us do these two separately. Okay, yes. So actually, we have to write the numerator as limit n tends to infinity. So the numerator is the summation. Okay. So of, so r to the power 1 by 3, where r is from 1 to n. Okay, so r to the power 1 by 3, 1 to the power 1 by 3, next term is 2 to the power 1 by 3, etc. Okay, so that is done. Now similarly, denominator. So limit n tends to infinity. Okay, now summation, but before that we have n to the power 7 by 3. So that we write as n square multiplied by n to the power 1 by 3. Okay, so 2 plus 1 by 3, so that is 7 by 3. We split this n to the power 1 by 3 because already we have r to the power 1 by 3, so we can combine these two. Okay, so we split it. Okay, next one, so the summation of, okay, so write it as summation 1 divided by alpha n plus r square. Okay, where r is from 1 to n, correct? So the first term is alpha n plus 1 squared. Similarly, the next term is alpha n plus 2 squared, etc. Okay, so this is the summation. Okay, let us simplify this. Now this becomes, so limit n tends to infinity, summation. So here, this n to the power 1 by 3, here r to the power 1 by 3. So we can combine these two. So r divided by n to the power 1 by 3. Okay, so this thing divided by, so this n square is there, limit n tending to infinity, so this n square is there. Now what we do, from this denominator also we are taking out n. So why do you take out n? Only then this n will come in the denominator. We need r by n. So to get it, so you take this n out. So if you take this n out of this bracket, it will become n square. So we will get 1 by n square and then summation. So this is alpha plus r by n squared. So that's it. Now we've got r by n, so that can be converted into x. Similarly r by n here. Okay, that's also this n square gets cancelled. Now what you do, we also have to divide by 1 by n, right? Divide by n. So 1 by n. So both numerator and denominator. So that this 1 by n becomes dx. So what is the rule? This limit summation, right? This limit summation is written as integral, right? Integral 0 to 1. Okay, so that is one thing. Next thing, this r by n can be replaced by x. So x to the power 1 by 3. And then this 1 by n can be written as dx. So that is the rule for all the limit summation question. So this limit summation will become integration. Integration 0 to 1. And also this r by n is x. So x to the power 1 by 3. And there is 1 by n, so that becomes dx. Divided by, similarly here in the denominator, limit summation. So that becomes integration 0 to 1. And then this r by n. So r by n becomes, so 1 divided by, actually it is in the denominator. So 1 divided by this. So 1 divided by alpha plus x squared. Alright, so this r by n becomes x. So alpha plus x squared. Okay, done. So 1 by n, so that becomes dx. So that's all. The rest of the things, simple integration. So let's do the integration. So this becomes, the numerator is x to the power 1 by 3. So that is x to the power 4 by 3 divided by 4 by 3, or we can write 3 by 4. So from 0 to 1 divided by, similarly here, so 1 by alpha plus x squared. So that has integration minus 1 by alpha plus x from 0 to 1. Okay, so simplify this. So just substitute 1 here. So we'll get just 3 by 4. That's all. So the numerator is simply 3 by 4. Okay, done. Denominator. So if you substitute the limits, if you substitute 0, this is 1 divided by alpha. 1 by alpha minus 1 by alpha plus 1. So that's all. So this is the limit. Okay, let us simplify this further. So this becomes, so 3 by 4 alpha multiplied by alpha plus 1, right? Because alpha plus 1 minus alpha, so that becomes 1. So this limit is what is given in the question. So this limit is given in the question, so that is 54. So that means we get a quadratic equation, alpha square plus alpha, so that is 18 multiplied by 4, so that is 72. So minus 72 equal to 0. So that quadratic equation can be easily solved to get the value of alpha, right? Alpha square plus alpha minus 72. So the product is 72 and then the sum is minus 1. So the values of alpha are, so it can be minus 9 or 8. Okay, so minus 9 or 8. So the sum is minus 1 and product is 72. That's all. So these are the possible values of alpha, which is minus 9 and 8, right? So that's all. So that is the answer to the question. See, this is the standard method of doing limit summation, right? But we have to get r by n. So that is our first step. So r is not enough. Just we need r by n. So that is what is converted into just x. So limit summation, r by n and 1 by n. So these are the three things we should try to get. So that's what we're doing here. Alright. So then it gets converted into integration, and so we got this answer, alpha equal to minus 9 or 8. We use the properties of definite integrals to solve this question, right? So let us take the given integral to be some I. Okay, I is the given integral. So that is 0 to pi by 2 and square root of 3 times square root of cos theta divided by, so root cos theta plus root sin theta to the power 5, okay, d theta. Okay, so this is the given expression. Now obviously we have to use the property, right, a minus x, right, f of a minus x, because cos theta is there, sin theta is there, and the limit is pi by 2, so pi by 2 minus theta, right? So you can replace this theta by pi by 2 minus theta, right? That's a property, right? F of x integral 0 to a f of x dx is same as integral 0 to a f of a minus x, so pi by 2 minus x, right? So that will give you, so 0 to pi by 2 and 3 cos pi by 2 minus theta, so that will become sin theta, so root sin theta divided by, denominator will be root sin theta plus root cos theta, okay, to the power 5 d theta. Okay, so that's it. Now we have to add these two, right? So add these two, we will get 2i. So So 2i equals integral 0 to pi by 2. What will you get? So this 3 multiplied by, so this is root cos theta plus root sin theta divided by same expression, root sin theta plus root cos theta to the power 5. So one value get cancelled, right? So one term, so that means power 5, that will become 4, right? So that is 1 divided by root cos theta plus root sin theta to the power 4. Okay, so d theta. Okay, now we have to do this integral. Okay, how will you do this? So we have to we can take out the common factor, right? This root cos theta we can take out, so that will become root cos theta to the power 4, so that will become cos square theta. So if you take that out, so it will become 3 integral 0 to pi by 2. So if you take out this root cos theta, so root cos theta to the power 4, that is cos square theta. If you take it to the numerator, that will become secant square theta. Okay, so that is the usual method, right? So usually when there is a square we will do this, but this method works here also. So you take this whole term out, so sin theta divided by cos theta, so that will become 1 plus root tan theta to the power 4. Okay, so that's all. Now obviously what do we have to do? So tan theta is there, secant square theta is there, so we have to do the substitution. Take tan theta equal to some t or something, or we can take some t square equal to tan theta because it is inside the root. So that means 2t dt. So that equals secant square theta d theta. So this secant square theta d theta can be written as 2t dt. So what do you get? So that becomes 3. Limit will also change, right? Tan theta. So that means 0 to, okay, so yeah, so tan pi by 2. So that is infinity. And this secant square theta d theta, so that is 2t dt divided by, so this is 1 plus t. 1 plus t to the power 4. Okay, so that's all. So this we have to simplify, right? Let us find this integral. Okay, so simplify this. What we have to do? So denominator is bigger, make the denominator smaller. The numerator can be any term, any number of terms in the numerator, no problem. But denominator should have only one term. So instead of t plus 1, you make it just t. You have to take another substitution. Or we could have directly adjusted here itself. But anyway, no problem. You take this t plus 1 as a new variable. So if you take, say, 1 plus t as some u, okay, then this will become, so same thing, right? 2i equal to 3 integral. So now t is 0, that means u is 1. So 1 to infinity and 2t dt. So what is the value of t? So t is u minus 1. So 2 multiplied by u minus 1. 2 multiplied by u minus 1 and dt. So dt is same as du divided by, so this is 1 plus t, that is u to the power 4. So that's all, right? So now it is easy to separate it, right? Because it has only one term in the denominator, we can easily separate it. That's why we did this. Or we could have also done something like this. You add and subtract 1. If you add 1, subtract 1, t plus 1. So 1 t plus 1 we can cancel. And similarly, so the other term. So we can easily do that. But instead of that, I have done some substitution. Okay, we can directly add, subtract 1 also. Yes, now this becomes, so this 2 gets cancelled. So I equal to 3 multiplied by, so we can split it into, so 1 to infinity is u divided by u to the power 4. So that is 1 by u cube minus 1 by u to the power 4 du. So now this can be easily integrated. So u to the power minus 3. So that has integral. So let us find the integral of that. So that is minus 1 by 2u square. So plus 1 by 3u cube. So here 1 to infinity. Now if you substitute infinity, it will become 0, right? 1 by infinity. So that will become 0. Only the lower limit you have to substitute. So 3 multiplied by, so this is 1 by 3. Okay. Yeah. So if you substitute the lower limit, so this is minus 1 by 3, right? Minus 1 by 3 plus 1 by 2. So that becomes, so 1. Yeah. 3 minus 2, 1. 1 divided by 6. So that is 1 divided by 2, or you can say 0.5. So that's all. So that is the answer. Okay, so 0.5. See, what we did is simple. So this is the normal method, right? This is the property we use for most of the questions of definite integral, right? A minus x. So that simplifies into this form. The numerator is gone at least. Now this is the method. Now we have to convert this sine and cos into tan and the secant, right? So that's all. So take substitution and then do this. All right. So we get the answer 0.5. Okay. So here also we have to use the properties of definite integrals to solve this question, right? The integral I is given as, see, this is I equals 2 by pi integral minus pi by 4 to pi by 4 dx divided by 1 plus e to the power sin x multiplied by 2 minus cos 2x. Okay, right. So this is the function given. Now you see the limit is from minus pi by 4 to pi by 4. So when you have an integral having limits minus a to a, we have to first check whether it is an even or odd function. So 2 minus cos 2x, so that is an even function. But this is neither even nor odd function, so we can't use that properties of even odd, right? So we have to try something else. See, we can use the basic property, right? F of a, f of x can be written as f of a plus b minus x, right? Integral a to b f of x dx can be written as integral a to b f of a plus b minus x, and add the two integrals. Okay, so that is the usual method we use for most of the questions. But here, because particularly this is of minus a to a form, we can try this method also. See, we have this formula, integral minus a to a f of x dx. So that can be written as integral 0 to a. So this is the property of generally any function f of minus x dx. Okay, the limit is from minus a to a. Particularly if f of x is an even function, so it will become f of x plus f of x 2 times f of x. If it is an odd function, so minus f of x. You understand? So that means it will become 0. So for odd function, this value becomes 0, even function 2 times. But here neither even nor odd, so we have to just use this formula directly. Okay, let us use this instead of using the first property. Let us use this property. Okay, so here it becomes 2 by pi. So integral 0 to pi by 4. Okay, now f of x is this function as it is, 1 divided by 2 minus cos 2x multiplied by 1 divided by 1 plus c to the power sin x. So that is f of x as it is written. Now f of minus x. So what is f of minus x? This function will remain the same, so 2 minus cos 2x. And this becomes 1 plus e to the power minus sin x. Okay, so 1 plus e to the power minus sin x. Okay, so that's it. So this is f of x plus f of minus x. Let's simplify this. You can take out the common factor, right? So pi by 4. So this 2 minus cos 2x. So that is same here. So 1 by 2 minus cos 2x. Then we can add these two. So this is the function. So 1 divided by 1 plus e to the power sin x plus, here this can be written as 1 divided by e to the power sin x. So that can be taken to the numerator. So e to the power sin x divided by 1 plus e to the power sin x, right? So dx. So that's all. If you add these two, we'll get 1 plus e to the power sin x divided by same thing, 1 plus e to the power sin x. So this will become 1. So this term is gone. We are just left with this. Okay. So that becomes 2 divided by pi integral 0 to pi by 4 1 divided by 2 minus cos 2x dx. That's all. So this integral is what we need to find. That's it. Okay, let's find this integral. Now this denominator is a linear combination of sin x and cos x, or sin 2x cos 2x. Then this is the usual method we do. Convert this into tan, right? Sin 2a or cos 2a formula. What is cos 2a in terms of tan? 2 by pi integral 0 to pi by 4. So this is 1 divided by 2 minus cos 2x formula. Cos 2x is 1 minus tan square x divided by 1 plus tan square x. So that is the formula for cos 2x in terms of tan. So if you take this 1 plus tan square x to the numerator, that will become secant square x. So this is simply 2 by pi integral 0 to pi by 4. So 1 plus tan square x. So that is secant square x dx divided by 1 plus, so 2 minus 1. So that is 1. And 2 tan square x plus 1 tan square x. So that is 3 tan square x. Now we have a combination of tan and the secant square. Obviously what we have to do? Take the substitution t is equal to tan x. So if you take the substitution t equal to tan x, the numerator will become dt and denominator is 1 plus 3 t square. So that is simply 2 by pi. And we can take this 3 out. Okay, so that will become simply t square. So it is 1 by 3. So 3 is taken out. The limit will also change. So tan 0. So that is 0. And tan pi by 4. So that is 1. So the numerator is simply dt divided by, this is t square plus 1 divided by 3. So it is of the form x square plus a square. right? So x square plus a square, 1 by x square plus a square, that is 1 by a tan inverse x by a. So let us use that formula here. So this is 2 divided by 3 pi. So 2 divided by 3 pi, and then so this is tan inverse, right, 1 by a. So 1 by a means 1 divided by a, here is 1 by root 3, 1 by a tan inverse x by a. So tan inverse x by a, this means t divided by 1 by root 3, which means root 3 t. So that is from 0 to 1. So that's all. So simplify this. So this becomes 2 divided by pi root 3 multiply by tan inverse of root 3, right? Substitute 1 here, upper limit, tan inverse of root 3. So that is pi by 3, and tan inverse of 0 is 0. So that's all. So this is the value. So this, if you simplify, you get pi gets cancelled. So 2 divided by 3 root 3. So that is the value of I, right? The given integral. So I is found 2 divided by 3 root 3. But what we need here is the value of 27 I square. So that means the 27 I square value is, so 27 multiplied by this I square value. So what is I square? This is 4 divided by the square of this. The square of this is 9 multiplied by 3, 27. So that gives you our required answer 4. That's all. So 4 is the answer to the question, right? So we simply use this property, right? What property? Minus a to a. So minus a to a, we have the limit. So then we can use 3 things. Even function, we can write twice of that. Odd function, we can get 0, right? And if it is not even or odd, so we can use that property. Okay, yes. Now if you don't want to use the property, so we can use that basic idea, right? F of a plus b minus x and add the integral. So that can also be done, but we've used this idea, and then we have to simplify. This is a normal indefinite integral question, right? After this, that's it. So this is a required answer 4. Here some relation between the functions f of x and g of x is given. It is given that the derivative of f of x, so that is f dash x, so that is given to be e to the power fx minus gx multiplied by g dash x, right? So let us simplify this. So e to the power fx, so that can be brought to the left hand side, so it will become e to the power minus fx multiplied by f dash x, so that equals e to the power minus g of x multiplied by g dash x, right? Now what we do, so we will integrate both the sides, right? So integrate both the sides, so we will get integration of e to the power minus fx f dash x dx, so that equals integration of e to the power minus g of x g dash x dx. Alright, we're just integrating both the sides. Okay, now how will you do the integration? Simple substitution method. Let us take f of x to be t, so that its derivative will be f dash of x dx. So let us take some t equal to f of x. So similarly here also you take some u equal to g of x, so that dt, what is dt? F dash of x dx, so that is already there. So that means this is the integral minus e to the power minus t dt. That's all. So that equals, so similarly here e to the power minus u du. So that's it. So this integration is minus e to the power minus t. Similarly here minus e to the power minus u, okay, plus c. Now this t can be substituted here. So what is t? F of x, so minus e to the power minus fx. So that equals minus e to the power minus gx plus c. Okay, now we've got the relation between the functions f of x and g of x, but some c is there, right? So we have to eliminate this c because we don't know the value of c, but it is given in the question that f of 1 equal to 1, f of 2 equal to 1. So that means, so let us substitute x value 1. Okay, if you substitute x 1 both the sides, we will get minus e to the power minus f of 1, so that is given to be 1, so minus 1, so that equals minus e to the power minus g of 1, so that is not known, we don't know the value of g of 1, so keep it as it is. Now similarly we can substitute the value of x 2. If you substitute 2 here, so we'll get minus e to the power minus f of 2, so that is not known, so keep it as it is, so that equals minus e to the power, so g of 1, so g of 2, so g of 2 is known, so that is also 1, so minus 1 plus c. Okay, so now we don't know the value of f of 2 and g of 1, and that is what we need to find in the question. So what we do, so we just subtract the two equations. Why do we subtract? Because we don't know the value of c, so we have to eliminate that. So just subtract the two equations. If you subtract it, so you will get minus 1 by e and plus e to the power minus f of 2. Okay, so that equals, similarly here, so it is minus e to the power minus g of 1, minus e to the power minus g of 1, and if you subtract, we'll get 1 divided by e. So let's simplify this, e to the power minus f of 2, so that equals, so 1 by e, 1 by e, so that will become 2 by e minus e to the power minus g of 1. Okay, yes, now we've got a relation. So we don't know both these values, right, f of 2 and g of 1, but e to the power something, so whatever it is, negative or positive, whatever this value is, e to the power that value is always positive, right? So this expression is always positive. If you subtract a positive value, the whole value will be less than 2 by e. So this value is less than 2 by e, because we are subtracting a positive value. When you subtract a positive value, so this value becomes smaller, you understand? So 2 by e, so e to the power minus f of 2, so that is less than 2 by e, so that means minus f of 2 is less than, so e to the power this thing, so that means a log. Okay, so log base e of 2 by e. Okay, so minus f of 2 is less than, so this is log 2 minus log e, so that is 1. Okay, so that means we can find f of 2 from this, f of 2 is greater than, okay, we are multiplying by negative 1, so it is 1 minus log 2 base e. So that's also, that is one of the answers here. So f of 2 is greater than 1 minus log 2 base e. Alright, so done. Similarly, we have to find the value of g of 1 also. How to find g of 1? So we have to again do the same thing, right? Instead of keeping this e to the power minus f of 2 on the left hand side, you keep this e to the power minus g of 1 on the left hand side, you will get the same expression, right? What is the difference? Instead of this term here, you will get this term, so you will get the same answer. I am writing directly. So similarly, so g of 1 is also greater than 1 minus log 2 base e, right? Because there is no difference, right? Almost the same steps you have to do. Okay, so g of 1 is greater than 1 minus log 2, and similarly f of 2 is also greater than 1 minus log 2, so that is the answer. Here the function f of x satisfies certain conditions. Using that, we have to find the value of f of 4. Okay, let's find it. See, it is given that f of x plus y, right? So f of x plus y equals fx into f dash y, so plus f dash x into f of y. So this is the relation given. Using that, we have to find the value of f of 4. So let us find it. First of all, what do you do? Let us substitute the value of x and y to be 0. You can substitute any value for x and y. So this relation is true for all the values of x and y. So let us substitute the value of x and y, so both 0. Okay, so that will give you f of 0. So f of 0 equal to, so f of 0, f dash of 0, again f dash of 0, f of 0, so that is 2 times f of 0, f dash of 0. Okay, so this is after substituting the value of x and y, 0. Okay, now what do you get here? F of 0 is not 0, f of 0 is given to be 1, so that means f dash of 0 must be equal to 1 by 2. So this is the value of f dash of 0. Okay, done. Now we can use it later. Now what you do, you will only substitute the value of y to be 0. Okay, let us substitute the value of y to be 0, not x. So here we substitute both the values. Let's substitute y to be 0. Why do you do that? Then only we'll get f of x. Okay, so let us find f of x. Substitute y 0, we'll get f of x. So that equals, so this is f of x multiplied by f dash of 0. So that is found here. So 1 by 2 plus f dash of x multiplied by f of y. So that means f of 0. So f of 0 is 1. Okay, so let's simplify this. So f of x minus f of x by 2. So that will give you this relation, f of x divided by 2 is equal to f dash of x. Okay, so let's simplify this further. So we'll get f dash of x divided by f of x equal to 1 by 2. Okay, so that's it. Now what we do to find f of x, we have to do the integration, right? That's all. So let us do the integration of this because it is in the proper form, right? F dash x divided by f of x, we can directly integrate it. So let us do the integration. So if you do the integration of the given expression, we'll get, okay, let me write it. So f dash x divided by f of x dx. So that must be equal to integration of 1 by 2 dx. So that's it. So f dash x divided by f of x. So that integration is known. So that is log of f of x. The derivative of the denominator is there in the numerator. Directly we can write log of the denominator. So log base e. So that equals, this is x by 2 plus c. Okay, now we have to find the value of c. For that, so we've got the value, right? We know that f of 0 is 1. So let us substitute x 0. If you substitute the value of x 0, we'll get log of f of 0, which is 1. Log 1 is 0. 0 equal to, so x is 0. 0 plus c. So that means we've got the value of c. So c is 0. So that means we've got log f of x. Log f of x. So that equals x divided by 2. So that's all. From that we can find the value of f of x, right? E to the power x by 2. I don't think we need the value of f of x. We want log of f of 4. So let us substitute x value 4. So that'll give you log of f of 4 equal to, substitute here 4 divided by 2. Okay, so that's all. So this is the required answer, log of f of 4, so that equal to 2, right? So that's also, that is the required answer. What we did is simple. So this expression is true for any value of x and y. Conveniently, we substitute the value of x and y 0 because that value is only given. F of 0 is given in the question. So to make use of that, we substitute x and y 0. Now to find f of x, we only substitute the value of y to be 0, and that becomes an expression like this. Integrating that, we will get f of x because this expression contains the derivative of f of x. We want f of x. So just do the integration, we will get our required answer, right? So that's it. So required answer, log of f of 4, so that equals 2. The integral given here has limits, but still we are going to use only the idea of indefinite integral. It is more like a question of indefinite integral. Finally we are going to substitute the limit, that's all, right? Yes, now here, so this is the question, integral 0 to 1 by 2, 1 plus root 3 divided by, so this is x plus 1 to the power 2, again power 1 by 4, so that is 2 by 4, so 1 by 2, x plus 1 to the power 1 by 2, and similarly 1 minus x to the power 6 by 4, so that is 3 by 2. So this is a standard question, right? So the two expressions having some rational power, right? Not integers, so only non-integers, right here. So we have to do this particular method only. So what we do, so integral 0 to 1 by 2, 1 plus root 3 divided by, you have to divide by this factor, or you have to divide by this factor. So any one of them, you divide by x plus 1, but power is 3 by 2, not this power. Or we can divide by 1 minus x, but the power is 1 by 2. Okay, so either divide by this or divide by this. Okay, so let me divide by this thing. So you will get x plus 1 to the power 1 by 2 and 1 minus x to the power 3 by 2. So you divide by this value, x plus 1 to the power, this power, so 3 by 2. Okay, yes, but when you divide, you have to multiply also. We have divided here, you have to multiply. Already the power is 1 by 2, we have divided by 3 by 2, so we have to multiply. So which means add 1 by 2 plus 3 by 2, so that is 2. Is that okay? So that we have to do. So you can also divide by this factor here. So now we have done this. Okay, now if you simplify this further, we get 0 to 1 by 2, 1 plus root 3 divided by, okay, so this is 1 minus x divided by x plus 1 to the power 3 by 2 multiplied by 1 by x plus 1 square dx. Now obviously we have to take the substitution. You can take this as some t, so that its derivative is this, because you see denominator u by v. If you find the derivative, v squared in the denominator, so x plus 1 squared you will get. So let us take this as t. So let us take t is equal to this value, 1 minus x divided by x plus 1. You can even take t square as this, because the power is 3 by 2, right? So the root is there, so that means you can take t square. So now you do the differentiation, so 2t dt, so that equals, so if you do the derivative of this, so that is x plus 1 square, right? And then, so this is x plus 1 multiplied by, okay, let's simplify this. So this is x plus 1 multiplied by minus 1 minus of 1 minus x multiplied by 1, okay, so dx. So that means this is equal to, so this is minus x plus x, that gets cancelled, so minus 1 minus 1, so minus 2 divided by x plus 1 square dx. Okay, so that is what is there here, right? 2 gets cancelled, so t dt equal to minus of dx divided by x plus 1 square, so that is there, so that can be replaced by this t dt. Now the integral becomes, so limit will also change. So when x is 0, t square is 1, so t is 1. And then when x is 1 by 2, okay, so 1 minus 1 by 2, so that is 1 by 2 divided by 3 by 2, okay, so that is 1 by 3. And then 1 plus root 3 as it is, divided by, so this is what we have taken as t square to the power 3 by 2, so that is t cube, okay, and then minus, so t dt equal to minus of dx divided by this, so that means it is minus t dt, okay, so that's all. So then this integral we have to do to get the required answer. So integral, so 1 to 1 by 3, and then so 1 plus root 3 minus, so minus 1 by t square, so dt, so that's all. So minus 1 by t square has integral 1 by t, that's all. So this is 1 plus root 3 multiplied by just 1 by t, so we have to substitute the limits, 1 by 3, okay, yes, substitute the upper limit, so this is 1 plus root 3, if you substitute the upper limit, so that will become, see, I've made a mistake here, actually this t square is 1 by 3, right, so the upper limit, so when you substitute x equal to 1 by 2, so it will become 1 by 3, t square is 1 by 3, so that means t is, so root of 1 by 3, okay, there is a square root here, so 1 by root 3, so that means this is root 3, so 1 divided by root 3, okay, yes, now substitute the upper limit, we will get, so root 3, right, so 1 divided by root 3, so root 3 minus, if you substitute lower limit, this is 1. Now if you do the multiplication, this is of the form a plus b, a minus b, so a square minus b square, so 3 minus 1 is 2, so that's all. So that is the required answer. See, these calculations are simple, but this idea is what is important, right? So you have to divide by this factor or this factor with this power, okay, so that one idea is what is important. The rest of the things, the normal calculation, okay, so the answer here is 2.